Kenneth is a Danish software engineer and architect. He's currently working at Intel out of Copenhagen, but previously also worked at Nokia on the N9 web browser and the WebKit. And today he will be talking about Project Fugu and how to bring a more native experience to the web. Kenneth, thank you.
Hi there, and welcome. As it was just said, my name is Kenneth Christensen, and just to say a little bit about myself, I work at Intel. I used to be a browser engineer for many years, but lately I've been working mostly on standards, trying to define like how the web should be in the future, making sure that it actually meets the needs of developers and users. So as part of this, I'm also elected member of something called W3C, that is the World Wide Web Consortium, one of the consortiums like standardizing the web, and I'm a member of the technical architecture group. So we work on making sure that everything on the web is aligned, and it's basically a lot of extra work for me in my spare time. So one of the things you might be asking yourself is like, why does Intel actually care about the web? And I think like this site from Microsoft really summarized this really well. It says that people actually using the PC or like mostly with Windows would spend like more than 60% of the time inside the web browser. So that's like 60% of the time inside the web using web technology. But it's actually more than that, because a lot of those apps that you are using might be Visual Studio Code, it might be Slack, it might be Teams, and these are all built using web technology as well. But then enhanced with a bit of native code as well. So about myself, like I really care about the web. I've always been a big fan of the web. It's what's got me into working with computers initially. And I really like the web because it's like it has this great reach and very low friction. It's basically everything starts with a URL, and you type this into your URL bar, and there you go. You don't have to wait an hour or 10 minutes even to download an application. These applications are also safe because everything lives inside a sandbox. But a lot more than that, like if you never go to a website again after a while, like the cache, all the files that it has stored on your device will just like be removed automatically, unless like with native apps where you install it and then you forget about it and they just keep on taking up your space on your phone, for instance. So this is what I mean with it being ephemeral. You can also link to these experiences by every website is basically shareable. You send this link to your friend and he can click on exact that link and he'll go into the website on exactly the same position. So for instance, if I find a tweet, I can send a link to that tweet. If my mom clicks on it, she'll see exactly that tweet. She won't be prompted to install Twitter and then having no idea how to actually find that tweet that I wanted to share. It's also composable, meaning that you can like embed a tweet by a politician inside a news article and the like. So if you've been to any web conference in the couple of years, you've probably heard about this thing called Progressive Web Apps, or PWAs. So PWAs are web apps that have been enhanced with a few of extra additional features. Like they're using something called a service worker that allow them to work even offline or with intermediate network. They're done in a way that they're fast and responsive and feel very native-like. So in a way, the web is really an amazing place to be. It has this worldwide reach. It works across major OSs, architectures, and form factors. It has a thriving open source ecosystem around it, even like with NPM, which is now even acquired by Microsoft, GitHub, and the like, a lot of JavaScript libraries. It's very flexible, so you can create experiences for books, applications, games, news articles, everything. Everything basically works on the web. And performance is pretty good. There are things that can be better, and it is becoming better over time. And there's also actually a lot of APIs. There's a lot of things you can do on the web that you might not believe you can do. But let's get into that a bit more as we go along. So to recap what PWAs are, so for instance, this is an example. I'm looking at my desktop, so I go to Pinterest. So this is one application that actually has a service worker. It has what is called a web app manifest, so that it can actually be installed. You'll notice in Chrome, if you look at the URL bar, there is this install part of it, the small icon. So if I click on that, it actually will prompt me to install it. If I click on install, immediately it will open up as an actual very native looking app. This app will then be in my, if I click to my application menu and all of that, the app will be there. And it will act just like any native app. So this is what a progressive web app is, basically. And the cool thing is that because of the service worker thing, you can make these experiences that even work offline by having the website actually download all the required resources and even try to get them from the web, or just get them directly from the cache. So the web in many places is really a great platform to be in. But sometimes you might want to do a web app and as your experience, but it might not be feasible for a lot of different reasons. It might be that one of those API that is really like the core of your experience is not available on the web. So say that you are creating an application for controlling your, say your flying drone, and it uses like uses Bluetooth, and you don't have Bluetooth support. Well, then you cannot do that on the web. You might also be a bit like scared about betting on the web, because we have seen that APIs come to the web really slowly. So you might be creating a progressive web app and having a lot of success, but you're very afraid that maybe in a year or 2 years from now, this like new amazing API is released, and now suddenly you don't have access to it, but your competitors have, and they take over your market. And there's really like a lack of this API roadmap. Like, people don't know when things will be coming to the web. So this creates a kind of distrust in the platform as a whole. So for instance, let's say that next year we're going to launch this magic source API, and it's just going to be magical, and it's going to drive a lot of traffic to competitors. And you have no idea like if this will ever be available on the web or not. So that's really, really bad. In some cases, you might be able to emulate the feature on the web, but it might also be that the performance is just not good enough. So you cannot really build a nice experience around it. So should I then just go native? Well, there's some people who have this idea that native is always better than the web, but it's not actually always the case. For instance, like the web is really frictionless. Things load quickly. You don't require any install, especially for things you don't want to install, like paying for parking like once in a lifetime. As I said before, you can compose things, embed foreign content, for instance, a tweet. You also have this declink ability where no install is required. My mom can immediately see that tweet without installing anything. And it actually does this ability quite well out of the box. Of course, it's possible to use a library on top that will break all of that, but it is really created in a way that it's really good. It can really work well with accessibility. Also native, like if you have like skilled workers that really know how to write in JavaScript and really know how to use the web, like this is like native is really a different skill set. And they're like different platforms, so you might even require different teams per platform. So also, as we have seen, that not all these native toolkits are created for different form factors. So this is something the web is created for today, but it has also taken a long time to get there. So we have responsive design and the like. But for instance, even seeing Android, like on Android tablets, they never became a success because the apps just looked at scaled up mobile apps. So all of this together can make this quite costly. You might be knowing that there are a few workarounds that you can do. For instance, there's something called Codover or phone gap or capacitor. Basically a way, or like on desktop, it's called Electron. Basically a way that you can wrap your web app. So you still write everything in web, but you distribute it in this shell of this native shell where you can also extend it. But of course, that really means, it doesn't mean that you're going to get the best of both worlds, like the best of native and the best of the web, because you do lose things like deep linkability. You also now are required to install things, so you don't get this like immediately just type in the URL and there you go. And you get like different native dependencies per platform. Also, if you really wanted to embed something, yeah, you can embed other websites and the things in your content, but you cannot be yourself embedded because you now have these requirements on native. So you might be wondering, like, how can we fix this? As I work as part of the Chromium project, we're always trying to like figure out what should we do for developers, and how do we make sure that we can regain this, the developers can regain their trust in the web. So you might be wondering, like, what is blocking people from adopting the web? Well, potentially you have existing, maybe even very high performance code that you really need to run on the web. So having to rewrite all of this in JavaScript, that's a big effort, and it might not even be fast enough. maybe the performance is not really where you want it to be, for instance, with scrolling and animations. And maybe you need to like create just your own toolkins or and the like. So and capabilities. Maybe you need these special APIs that are just not available on the web. But it's actually not so bad. If you look at like the existing code, like we have a new standard called WebAssembly that is also getting support for what is called single instruction multiple data and threads. This allows you to take your C and C++ code and with time other languages as well, and bring it and run it in the browser sandbox. In the future, we'll also get like Web GPU will be a performant way of doing graphics. With regard to scrolling and animations, we're also having a lot of things being worked on to make that much better. So that should come here. So for instance, off screen, off the main thread, we have something called comlink and a platform worker where you can run like your logic basically in another thread. So that really helps a lot. You have the CSS Houdini, which allows you to get like this animation worklet and CSS paint, where you can also paint off the main thread. This is not all there yet, but it's coming. And we're also getting a new thing called sub-tree visibility, where you can basically avoid painting what you don't need initially. Being able to do something like a virtualized scrolling list without actual visualization means you can still do things like search and page and the like. For toolkits, this is partly solved with something called web components, and there are now like very good component sets built on top of it, like Material Web Components and Ionic. And different companies are creating their own design systems, such as SAP, Salesforce, Adobe, and the like. And with capabilities, this is what brings us to Project Fugu. So for instance, with WebAssembly, Autodesk actually managed to bring their 35-year-old code base to the web. So they have this project called like AutoCAD, and they brought all the 2D parts of it. This counts for like 90% of all files. They can now run in the web browser. So this is really cool, very nice example of what you can do on the web. But people that really want to work with this might want to work with local files. You can imagine if you're doing like a video editor, it might be really slow having to upload all these large files to a cloud service before you can actually do things. So this is where the Project Fugu comes in. So Project Fugu was a project initially started by Google as part of the Chrome project, but quickly it was joined by both Intel and Microsoft, as we have a shared interest in making the web work really well for developers. So Fugu is the Japanese word for the pufferfish. So this little cute fish is also called a blowfish. It's actually delicious in Japan. It tastes really well, but you have to be really careful because if you cut it wrong, you will leak some poison and you will actually die from eating it. So it's delicious if prepared correctly, deadly if not. And that's kind of how we see the whole Project Fugu. So we're trying to enable web apps to do anything that native apps can do by exposing these capabilities of these native platforms. But we want to do it in a way that we still like preserve like user security, privacy, and trust, which are like the core tenets of the web. So there's a URL here where you can type in your browser and read a bit more about how this whole project was started and what are the plans for it. There's also a bug tracker where you can see like what is going on, how people are working on these new APIs. But what I find the most interesting is the Fugu API tracker, which basically shows you a list of the priority 1, 2, and 3 APIs being worked on. It also has a small G, I, or M, depending on which company is leading the effort. And then you can kind of see the status, whether this is already shipped, when it's supposed to be shipped, if it's in what's called an origin trial or not. So the process for bringing something to the web, like when I started working on standards, on average, a new spec took around 6 years, and that is way too long. So we're really trying to accelerate how to bring these APIs to the web. So the way we do that is by identifying the needs and use cases. This is by talking to developers and talking to like partners and figuring out like what exactly they need. Then we write an explainer, which is basically a document that explains you how these things are supposed to work together. And doing all our research, have people tried to do this before? what are the different solutions, which solution have we abandoned because of one reason or the other. Then we solicit feedback from developers and other browser vendors and iterate on getting like a good implementation and specification. Then at some point we end up with having a formal specification, and then we turn it into what's called an origin trial. We'll talk about it in a moment. And then eventually we ship it. So an origin trial is this thing where when you have an API, normally it's first landed in a browser behind a flag. It means that the developer will have to go into the browser and manually turn it on. It sounds a bit scary, and like it's fine for development, but you cannot test it how it will work in the deployed environment. So if you have a business that really want to use one of these APIs, you'd really like to try it with your actual users and see how it works. By this, we have an origin trial, which basically you can sign up to get a token for this specific feature. It will give you a token which will run for one version of your browser. So one version of Edge, one release version, and one version of Chrome. And with this like token, you'll put it into your website, and it will be enabled for most of your users in that time. Not always for all of your users, because the idea is that you should not depend on it, because it will change in the future. And even when there's a new version of, say, Edge, it might have a different API where it slightly changes, and that's why you're required to register for a new token. This way, you'll also be able to give like the feedback to the people working on these specifications, what worked well for you and what doesn't work. So now we talked a bit about like Fugu, what's the plan? So you might be wondering, like, what are we actually working on? Like, what are some of these exciting APIs? So I just chose some of them, which I find are the most interesting ones, and we'll have a look at them. So I'm really keen on hardware connectivity. I think it's really interesting. So let's start out with that. So actually, one of the things that started a bit before the whole Project Fugu was enabling web apps and web application to talk to Bluetooth and USB. So we created like, for instance, the Web Bluetooth standard, which allows you to create a web app that actually talks to Bluetooth over the Bluetooth protocol. I have a talk about that. I don't have the time to go into all the details here. So if you want to check that out, you can check that out later. Web USB is the same as Bluetooth. It just allows you to talk over the USB cable and create experiences that way. So this might be really good for companies where you have like machinery, maybe in a hospital, and you need to control these. I know a friend of mine actually worked at a company where they're doing these like CPR dolls, and they could either talk using USB or Bluetooth and do all the experiences just using the web. This is actually shipping in Chromium-based browsers today, but people are working on a few additions. There's also a serial API. So over USB, it's very common that people actually use serial. So a lot of people think, why don't you just use the USB API then? And the reason is that serial is basically often handled by the OS itself, the operating system, which means that the operating system will claim this device and you won't get access to it from the web. And being able to like go and change the firmware of some of the devices might not always be possible. So Web Serial basically allows you to talk using the serial protocol as well. This is currently in an origin trial where we're getting deployment feedback from people actually using it. There's also another protocol also created for USB called Human Interface Definitions, also called HIT. This is very common for like keyboards and mouse. And of course, we don't want like the web app to take over your keyboard because it's really something that is tied to the OS. But a lot of people use like this web HID for a lot of other, or the HID for a lot of other devices, such as, for instance, Gamepad. So we're also bringing that to the web, and that is currently behind a flag, so you can play around with yourself, but it's not yet an origin trial. At Intel, I have myself been involved with called NFC. So this is like the near field communication. So these are NFC chips. They're very common in phones, for instance, used for payment like Apple Pay and Google Pay. And we've been exposing what is called the NDEF, the NFC data exchange format, to the web. So this allows you to read and write NDEF records to and from NFC tags. It has very complete NDEF support. And we have a lot of demos, and there's even a nice article on web.dev/NFC that explains you all of these details. So I think it's really cool that I got to show this in Japan. I got to show this to the inventor of the web, Sir Tim Berners-Lee, and he was even quite excited. So I have a small example here. It should play itself. Let me click. This is, for instance, a game that's developed using NFC, where basically we'll show you. There's a lot of noise there. Sorry for that. So it'll basically. It's basically a little game where we'll show you like which cards to tap in which order. I also created a shopping list. So this is a grocery app, what you need to buy every day. And you can see you can check it all off, and you can re-add things, and you can even remove them for good. And here I'm like adding some new ones, but instead of just like writing it manually, which I just did here, I'm now going to write it to one of these NFC stickers instead. So now I'm writing that I need to buy NFC tags for my demos, and I press write to NFC tag. So I say touch your NFC tag now, I'll touch it. And next time when I press these, it will actually gonna like re-add things to my shopping list automatically. You see I got NFC tags there. So this just like shows you some of these things you can do using these new features on the web. It's very simple. I'm just showing like overview of like how easy it is to, you just create a reader, and then you basically subscribe to reading events, and you even have a way, and then you like start scanning. So you scan for cards. So whenever people touch one of these tags, it's gonna like trigger this event. Then you get like different types of records, because there can be different types of record on NDEF. Like I could have like some JSON, or I could have a MIME type, and I can read each of these manually. Writing is basically just like creating a writer and writing JSON basically. So very simple API. This is currently in an Origin trial in Chrome, so you can already deploy this on your websites and play around with it. Intel also worked on sensors, because we already had sensors on the web, like there's an orientation sensor, there's accelerometer, some kind of like high-level sensors, like I think it's device and motion sensors and orientation sensors. But all of these had all kinds of issues. Like you could not configure, for instance, the frequency. So maybe you don't need a high frequency, which is draining battery life. That was not possible. They're very high level, so browsers implemented them in different ways, which introduced interoperability issues. No timestamp, so you couldn't do what's called sensor fusion. They were not generic. A lot of issues with privacy and the like. So basically, we decided that trying to fix these would just end up with still like a suboptimal solution. So we created these new sensor types that are like generic and low level. So you have like an accelerometer, gyroscope, orientation sensor, like absolute orientation sensor, relative orientation sensors. And all of these are today implemented in Chrome, except the ambient light sensor, which we hope to be shipping soon. Playing around with sensors is actually really, really fun. And if you have any interest, I encourage you to check out this other presentation I did about sensors a while ago. Here's one example. Because these are generic, I could kind of like emulate the same API. So I did this application that actually uses my phone, the gyroscope, and the accelerometer. But I had this IoT device. So I took this IoT device and implemented the same API and connected to it over web Bluetooth. And I just showed you here that also just worked like seamlessly. So I think it's really nice to see all of these things come together. Some people might say, well, this is cool, it's in Chrome, but I really want to use this on other platforms, such as iOS, which doesn't support it. For this reason, I wrote a polyfill, a small library that will mimic this new API on top of the existing APIs. Of course, you won't get like the configurable frequency and the like, but apart from that, it works pretty well. Something else on the web, which is like core to the web experience, is sharing content and actually receiving these shares as well. So this is not possible for the web today. You can share a link, but you might want to share a bit more than that, and you might also want people to share into your experience. So for instance, we have like web share. So this is web share. For instance, you see, I want to like share something from a website, and I wanted to bring up this like sheet that I have on my phone or computer. and where I can choose the application I want to share it to. Very simple. You basically just like say what you want to share, and then you call the navigate.share function. But you also want to, if you have this application installed as a progressive web app, as I have with Twitter, I also want for any app, even from a native app, to be able to share into Twitter. So if I'm on Instagram, I think, oh, this is a nice picture. I really want to tweet that to my followers on Twitter. I want to be able to do that. And this is where Web Share Target comes in. So this is part of the web app manifest for progressive web apps. There's basically an extension where you configure how to receive these shares. So this is actually shipping already today, but it's not possible to currently share or receive shares of files such as images, but we're working on that. Something else that I looked at a bit initially with the screenshot of AutoCAD is that a lot of people really want to be able to read and write to files directly. Today you need to do something like Electron, for instance, Visual Studio Code works with your files when you're programming on, and they're normally on your computer, not in the cloud. And in order to be able to do that, you need access to the file system. So we're also working on this native file system API, which allows you to have access to the file system for a session. There will also be the possibility that, for instance, if you've installed this progressive web app and you reload it, it will be able to get like a serialized handle of the files or directories, so you don't have to ask and prompt for access every time you want to access the file system. So this is also really nice. We're trying to come up with a modern API that makes it really easy to work with files, just like how you work with other data sources on the web. So this is currently in an origin trial. They've made a few changes to improve the API, listening to the feedback of developers, and are launching a new version of the origin trial very soon with these new updated APIs. Another thing that's really important and core to the web is media and playback. So for instance, if you want to do something like a Spotify progressive web app, it would be really nice if people, without having it open, that you can actually control, maybe seek even, and do like next song, skip this song, and the like. And for this, we have the media session API. This is all, and even make this work on the keyboard, because you have these like actual keys on keyboard to maybe seek or to turn up the volumes and play and pause. So this is also a very simple API. A lot of like callback handlers where you tie into these events, and then you can like handle what you want to do when these events trigger. Very easy, and this is actually shipping already. At Intel, we've been working a lot on actual like media streaming, like media capture, allowing like the camera to get access to all these like more advanced features, the filters. So we can do interesting things like this example here. Some of my coworkers created. We can do this funny hat things where they can paint on top of my face. We're also working on adding support for like pan, tilt, and zoom control, which is very important for applications such as like Microsoft Teams or Enterprise Hangout, where you have a meeting in a room and you maybe want some AI, or maybe want people to manually control the camera to zoom in on who's talking and so forth. So here's one example where my coworker is showing that he's actually tilting and panning one of his cameras. And this is shipping most of it today, but we're still working on the zoom, pan, and tilt. At Intel, we also have some real-time cameras. They basically have this like something like on the new iPad Pro, we have this LiDAR technology where you can actually measure the distance. So this really allows you to really do like background removal in a really good way without relying on guessing how far away pixels actually are. So here's an example of another coworker of mine did, where he actually showed that he can manipulate WebGL just by using this like depth sensing camera. And I think it's pretty amazing to see what is possible by bringing these things to the web. So you can even pick up a box here and put it on top of the other one. It's pretty amazing. So these extensions to depth streams, because depth stream cameras are not that popular yet, are currently behind a flag. So you can play around with yourself if you have a compatible camera. Something else that's very important, and we've heard a lot of people request, is like, why don't we get code on the web that allows us to like scan barcodes? and even faces, because like this is a very common thing. Like you maybe want to track inventory, and yes, you can rely on some JavaScript library. First you gotta load it, and it might be really slow, and it might even like drain your battery. So if the phone and your device already has all this, like maybe in hardware, why not expose it? So this is where we have the shape detection API. So this basically allows you, for instance, to detect different kinds of shapes like faces, barcodes, and the like. Very simple API. It works on an image, so if you have a video stream, you need to give it every image. This is currently behind the flag, but it's the barcode support is shipping very soon. Something else that we're working on is system integration. So if you create these applications, you really want them to integrate in the system like the OS, so they really seem as an integrated part. One thing could be if you have the application tied to your panel at the bottom of your screen, you might want, when there's an update, like you got a new email or a friend is typing you, or you have a new calendar invite, then you really want people to be able to batch you, to show that, wow, you have 5 unread emails and the like. So this is where we have the batching APIs coming in. Very simple API. Some APIs, sometimes you can just set like maybe a number. Not every OS is able to actually show that. For instance, on Android, you always just get a dot, but different OSs might be able to actually show the number. So this is also very, very close to shipping. Something else, this is something I've worked on myself, is dealing with having to keep the screen alive. So imagine you created this nice recipe application and you want to cook. I love cooking. So I put my phone on my laptop next to me in the kitchen, and I have dirty hands, and then the screen turns off. It's like really, really annoying. And for a company that's working at Intel, really don't want people to go into system controls and turning off the screensaver and all of this, like generally, because like they're never turning it on again, and they end up getting like really bad battery life and complaining that our devices are not good. So being able to like request when you need the screen to stay alive a bit longer with still having the system some control. For instance, if you're on battery save mode or you're low on battery, you can still say, okay, sorry, you're really low on battery, we're gonna turn it off, or at least like dim the screen. Having that ability is really nice. So people really don't want to end up in a situation where you get the screensaver, especially when you're cooking. So this is where the wake log API comes in. So this is useful, but even for like something like Google Maps or cook a recipe and the like, or even like showing a presentation like I'm doing right now. So currently there's like 2 different logs. There's a screen log for not turning the screen off, and there's a system wake log for not actually turning the computer off, like going to deep sleep, for instance, if you're doing some background work. So very simple API as well. You request by user action, you request one of these logs. So there needs to be like the user needs to touch the screen and do something. And then like you can release it whenever. If you go away from the website or do something else, well, then the log is released automatically by the system. So there's a lot of thought into the specification on how to avoid abuse of this. So this is currently also an origin trial in Chrome. So we're currently getting the deployment feedback. For instance, the Google Slides is using this API. In third world countries, especially, we've had a lot of companies that really want to bootstrap applications like social applications. So they really want to get access to your like phone contacts. And this is often like a big issue because like it sounds pretty scary. So you don't want to have permanent access to your contacts, and you really want the users to be in control of what they're sharing. So this is where we have the contact picker API. It basically like shows you like, okay, these are the contacts you will share. These are not shared with the website before you click OK. And you can decide what you're sharing. For instance, I'm only going to share the email. I'm also going to share the phone number. Very simple API. You say whether you need to be able to select more than one, or if one is good. What you want to like share, like name, email, telephone. The user is still in control. They can say like, no, I'm not sharing email. And then you basically just call like navigate.context.select. If someone selected me, you would get a JSON array back with all of these selected contacts. Very simple API to use. So this is shipping in Chrome currently, Chromium browsers on mobile. And but we're still working on some additions, and it would be, of course, nice to have something like this on desktop browsers as well. We're also doing some early exploration around font access. So a lot of these like design applications like Figma and the like, when you're designing something, you really want to have access to your local fonts. And you don't want to upload these for every web app, and it's very cumbersome, and maybe you don't even have the license to do so. But like sharing fonts or giving web app access to fonts is like kind of dangerous, because it's really easy to fingerprint who you are by which fonts you have installed on your system, because it's very unique. So we're really trying to figure out like ways that we can get around this and still enable these new design applications to be built as progressive web apps. One of the things that Microsoft and Intel has been working on currently is dual and foldable screen support. So we're getting all these new devices that have either have one screen that you can fold, or then maybe have two screens that can still be folded, but they're actually two physical screens. So for instance, you see on this screen, you see one screen that actually has a foldable display. But some other devices might, like the Microsoft Surface Neo, actually has two different screens, and there's a hinge in between. So you might have run like two different applications on this device, but in some case you might want to like span the application to use the whole display, thus both screens in the case of two screens. But then you get this thing in the middle. So for instance, this is an example we wrote at Intel. So this experience, this is using the Windows 10X emulator. I span it, and you see now the images are cut in the middle. This is really not nice. This is not the experience that we're looking for. We really want to be able to control how this should lay out when you have two screens. So you want to do something like this. You want to know where it's split. You want to be able to lay out like this. So this is where we have the spanning CSS media feature that allows you to control what is shown where. So there are some media features you can request, and there's also some environment variables, so you can create these experiences that span nicely across two screens. So this is, for instance, the exact same demo I just showed you before. This is how it looks on this with this new API. So you can really see that it's possible to create experiences that work well across two screens. This is behind the flag in Microsoft Edge. You can play around with it if you have Edge installed in the Windows 10X emulator on Windows. Another thing that Microsoft is working on is customizing the title bar. So if you have this, especially on desktop, you install your progressive web app, it just gets like a regular title bar. But as you've seen, a lot of applications, they actually make use of the title bar. For instance, Edge itself or Chrome, they have tabs up there. You see that Visual Studio Code have like a menu bar. Teams has the search bar. So we want to be able to do this, but you also want to be able to do it in a way that these applications cannot spoof you. So you don't go to like evil.com and it makes the application look like Chrome, and you think you're entering your bank details, but you're entering into the wrong applications. So there's a lot of thought about this. So some of it will be trusted UI. So if you look at the examples at the bottom of the screen, you'd see that it will show, for instance, the URL while you're loading the web app. And there will be these buttons that will always be there. So you'll be able to create the rest of the experience yourself. So you can still do something like Visual Studio that will look the same, but it won't give you exactly the full flexibility, because there's a balance between like privacy and trust and security and actually the feature. So this was a kind of like overview of some of these things we've been working on as part of the project Fugu. So if you look, like, you might not believe that the web is capable of doing all these things, but this is actually a list of what you can already do today with a Chromium-based browser. So you have access to vibration. This is something the Twitter progressive web apps just started using. So I'm using on Android. So if I do pull to request, it actually gives me the feedback, like it just shakes a little bit. So really feel that is understanding what I'm doing. You have access to USB. You can record media. You can use Bluetooth. There's all these features. But if you look forward, and even like this year, like we really have the plans to expand this like a lot. And the whole idea with Fugu is that we want to we have this gap between native. We want to fill it and want to do that pretty quick, but of course, high quality and good security and the like. But we really want to accelerate how fast we can do things by collaborating That's why we're collaborating Intel, Microsoft, Google, and even other companies like Samsung. And then from there on, we want to make sure that like when these new APIs come to the web, that we kind of have a roadmap for how quickly they will be available to users. If you have something that you need for creating your experience, you can go to this URL, bit.ly/new Fugu request, and you can actually file a request and explain why this is very important for you to create your experiences on the web. And with that, maybe we'll consider it and maybe even see if we can find out like who is supposed to be working on this. So with that, here's some examples where you can find more information about the API tracker, and also a landing page where you can learn about the project as a whole. And with that, I would like to say thank you for your attention.